Okay. Once again, good morning, everyone. And thank you for joining us today. Today, we have a session on the System Design Masterclass, turning raw data into decision intelligence. And before we get started, let's quickly understand why the today's session is most important. So, system design is no longer just a interview topic. Today, as applications becoming more AI data driven, professionals need to understand that how data moves through a system, how architecture supports scales, and how decisions are made. So it's not just about writing code anymore. It's about understanding systems, data flow, context, and engineering judgments. And that is exactly what today's session is focused on. So now before we get started, it's my pleasure to introduce our today's speaker, Suchit Bhatwadekar sir. He is a CTO coach at IIT Kanpur and IIT Roorkee. He is also a Stanford AI professional and a member of Harvard Innovation Center Circle. Suchit sir brings strong experience in technology leadership, system design, AI data, and real world engineering decision making. Today, he'll be sharing with us practical insights on how modern systems are designed to convert raw data into decision intelligence. So, the session of today is designed to be more practical and career focused. So, I would request all the participants to stay with us till the end and follow the flow completely. And I would also request them to turn on the camera and make the session more engaging. Also, please feel free to drop your questions in the chat box. We'll try to take it during the session or towards the end. With that, let's get started. Over to you, Sujit sir.
Good morning, good evening, and I think good afternoon. I'm seeing the whole crowd is across the globe. It's not only in India,
Yes, sir.
and I'm extremely happy about that. I'm so happy about it, rather. So, what we're going to do is that I'll just give you how exactly this whole session is going to be walked through. And then we are actually going to conduct. So while this session is going to go on, you will be also asked to do few exercise for yourself, right? And those exercises will help you to rate yourself that what you learned, and that will become your report card for yourself, not for me or not for Board Infinity or something, but it's for yourself. So I'm going to explain you those whole thing. The one caution which I want to highlight to all of you is that the session, because it's a cram session and the subject is very vast, subject is very important. The questions, answers, we will take it in the end. Okay. But I will ensure that I will go slow, and whenever you will have a question, make sure that you make a note. The one more instruction for all of you is that make sure that you will have a pen and paper with you, or paper and pencil with you, because if at all you were not able to put into a Padlet is what we're going to use it for you to put your content or put your inputs, whatever you're learning. If you are not able to access it, if there's an issue, we may not be able to help you out very clearly on that. So better you should have your own particular pen and pencil. Okay, so these are the few instructions before I start off with. Okay, so Deepali, shall I start? Any other technical issues? Nothing, right?
No, no, everything is started. We can start, sir.
Very nice. Again, good morning, good afternoon, good evening to everyone, and thanks for joining in. Okay, I'm going to share my screen. That will give an idea about how exactly we're going to take you through the various different part of this session. I'll not introduce you myself to detail. The reason because of only one generally I follow in my professional practice is that I first I'll focus on what the content I need to deliver. If you really like it, of course, that will certainly make sure that you will certainly want to know about me, and that's something which I will forward you or give you on the end of the slide. But my intent would be more focused on the content and try to see how we can learn something that about me, who am I, kind of a thing, right? Rather, what I learn is what is important than what I am currently. So the table of content point of view, what you're seeing, I'll just go slow, just absorb for a moment. Become an architect of intelligence, right? And I think whether you become a builder or not, but whether if you are become an architect of specifically intelligence is something is what most of your career depend on going forward. Because all of you know that engineering has been taken care by largely in AI and it will increase further. So what is your intellect? What is your architectural understanding? What is your system design understanding is very important. So what that mission, what we're going to do in this session is that we will take one problem and you need to take rather one problem in a Padlet and I'll explain you the Padlet. How does it look? Wait for some time. It's a wall and on that wall you're going to put your problem and everything and we will whatever the whatever the learning what you have in us one step by step, right? You can add those based on the instruction which I'm going to give you. The topic is decision value. Now I deliberately not talking about AI, I'm not talking about GenAI, I'm not talking about agents, I'm not talking about anything else. Because if you understand the value of these decisions, decision is something is very important. Decision actually carry the highest level of value in terms of enterprise point of view, and very simple reason because models today are able to do a reasoning to the certain level, but they're still not able to do a planning and decisioning. And enterprises run on decisioning, right? They don't run on anything else, and that's where the largest that is the largest kind of a dollar value is going to come out in future. And that's why you must be seeing how exactly all the models are focusing on enterprises in their strategy. That's why decision is very important. And there's something new which I would like you to know about it more than the GenAI. Now, what you will learn is decision anatomy, which is what I just mentioned. Because if you learn how to design decisions in your AI and your systems, whatever you're going to, the problem you are taken, using all these things, let's say an objective, evidence, context, model, policy, and everything, right? So if you're able to understand whole thing, you will go beyond GenAI, you'll go beyond thing what you're doing currently. And I think you will be able to really differentiate yourself when you're going to present your case, that how your system will be a decision-making system, not in kind of only the reasoning engine or a GenAI with a generative AI kind of, right? What you're going to do is that if you're able to rather, I mean, I would say that if you're able to come out with your decision value as a part of your problem statement, we will also discuss about what architectures will require to make those decisions right kind of thing. And then one of the hot topic is context engineering, what all of you know. I'm actually adding the decision engineering also on top of it, which is what about to come in next 1 year kind of thing. So you'll be in the first people will be knowing it, what exactly is coming in AI perspective, right? So context and decision engineering. And then finally, how the context graph is one of the solution. It's not the final solution, but how exactly the context graph is going to help in terms of a decision engineering kind of thing, right? So that's the way the whole table of content you will go through. I'll skip the other content. What we will do is go now. We'll go to the next session, next slide. Summary. We are actually going to talk about largely how that particular part of the world where you're going to see a high potential from the career point of view, from the architecture point of view, from AI point of view, where the things are going to go, right? It could be little new for you. It could be known to you also. Depends on which field you're working on. Because I'm seeing that there is a mix of um, rather it's a very fantastic mix in this whole cohort is that coming from a graduate, undergraduate, researcher, professional from 0 to 3, and then manager and decision maker kind of. So it's a very perfect thing if you're coming from agent architecture, if you're coming from completely a data architecture. Nonetheless, this will relate to you in all aspects because that's the way the future is going to go. Okay. The largely, if you really see, currently there are two different apps which is at least making a wave in intelligence era of what we are into today. One is called agentic AI app. All of you know about it. One is called data or the decision apps. which is ultimately erstwhile we used to call them as a dashboard. We used to call them the probably a good word could be the analytical apps. And now there is a advancement in terms of data lakes and so kind of right. Uh, but those are also largely are the one which is what a part of an overall ecosystem of AI. Both are getting impacted through AI, as all of you know, and both have equal revenue or the margin attached to it kind of thing. Rather, I would say that decision apps would certainly, or the decision engineering would certainly take over forward. So the question remains for us is that what is the decision environment you are going to create for your apps? Doesn't matter whether you are in, as I said, into an agentic app creation or whether you are in data app creation. The question is that will you be able to not create a reasoning environment, which is what already have it, but something decision environment. And when we say decision environment, I'm going to give you a few example before we start. So those who will have a question, what is the decisions means and what does it, how does it relate to a real life example? Whether the decision is be an ultimate AI end or not, or whether how it is attached to revenue, who's really making money out of it, who's going to make a money out of it. All this question I'm sure you will be having. As long as you understand the first fundamental word called decision, I'll move forward. Now, the good part of this new AI era, the new decision engineering, I would say, or decision intelligence, whichever the word you want to say. And when I say always, I repeat once again, and that what are the apps we are developing today is only a certain level into the reasoning app, whichever the one what you're seeing, right? The simple reasoning app, we moved from last 3 years to reasoning app at the max. Are those a decision apps? No. Are they taking a decision on behalf of you? No. Will they require to do a decision on behalf of you? Yes. Will that change the economic value because they will become a more decision oriented than just reasoning oriented? Answer is yes, right? And that's why this gap from reasoning to a decision is what something very important. I'm repeating the same thing, but I just wanted to be telling you the same thing on different way for initial purpose or initial slide. Afterward, we're going to go a little fast. See, what matters is if you really observe in this whole thing is that whether you apply, because in this whole new era of reasoning moving to a decisioning kind of a thing, how is your engineering judgment is going to work out? Reason, your human engineering is very important because this is the world which AI has not seen. The decision what we generally take as a human, AI has never seen it. AI cannot see also, right? AI only can see the text. AI can only infer something that some decision has been made because of XYZ, but it actually is not the logic, the algorithm behind that decision making is not something what AI understand because it doesn't know the world knowledge in terms of the physics, the way it's supposed to be, the way we understand. Even the 5 or 6% what understand about physics is not been known to an AI kind of, right? Same thing in the business, and the business something which all of you know that model or the whatever the models so far we have seen or the frontier model, they have actually got all these 14 trillions of a token, but nothing from enterprises, right? An enterprise actually run the business and actually has a process, actually has a kind of a policies, actually has a kind of a rules, right? Which has not been known to AI and so. Of course, there is an attempt that's going to go forward for it, and that's what the future is all about, right? But today it is not. But what I want to convey in that one, that as long as you design the way you see the future, your engineering judgment on what the future is, and the way you apply that and make the AI work for a decision engine, you'll be the winner. So you need to have this engineering judgment. That's what I call engineering theta. I call engineering judgment is what something is the learnability which you need to have in future, right? Finally, what the outcome we need to have is the reliable actions and what are the measurable output from that or the measurable learning from it, right? Okay, now little, I'll take a pause, but little, you don't need to worry about this too much verbose slide. This is your learning journey. At this time, what you're seeing in front of you, the top level few boxes, you will You're going to fill up those one by one, is what going to happen. And you don't know anything of that so far. You may know few of them. You may not know what the relation, you may not know what exactly it means. And that's a job which I'm going to do, that I'll give you Padlet. We'll spend 5 minutes and update the Padlet. You will start with putting your problem and outcome, what you're looking at. And slowly, when you go through the each and every slides, I'll take a pause and then ask or request you to put those input. You know what? The good part is that if you able to either do it in pen and pencil, it's okay. Even if you do on the Padlet, which I'm going to expose you, whether you will able to reach to the very fantastic conclusion at the end of the session, it actually doesn't matter. What matters is that you will know now the path of how the decision making is going to happen in machines going forward, and what you are going to do in engineering around it, right? Now, because of the time what we have, we may not able to take in questions, so I may not able to help you in some clarification and everything, but that's fine. As long as you have this skeleton with you in future, it will be a fun to take it forward and do your own research also going for. That's how the Padlet I'm using it, right? Now let me not explain all these boxes, because as I said, it will happen automatically. But let me see whether huh. So what I did, let me first expose you to Padlet, introduce you to Padlet. Okay. Yeah. And I'm going to show you something. Padlet here, Padlet here, Padlet here. Okay. You will see something like this. Just to cross-check myself whether I'm showing you something what you are seeing it. Deepali, you are also seeing the screen, some web page.
Yes, yes.
Okay. So all of you would be seeing some Padlet, and I have created some they look like this by clicking on this post and everything, which after I give you the URL. But what you're going to do is that once I will share with the URL, I'm going to give you some this structure in Zoom. You just need to copy paste and create your own particular uh, pattern. Now you may have a login issue, you may have something, and also we're going to give some time for all of you. Some people may not able to join, some will have an issue, but it's okay. Even if you get few, fine. If you get all, it's fine. But we will avoid any, will not have kind of a system issue solving in this whole thing, because it may take a little longer. That's why I'm saying your pen and pencil should be okay to run through with this exercise, what you're going to do, and how you come out of the decision engineering. Okay, so now what I'm going to do is first I will paste on chat, which will be for everyone, with something like this. You'll start with your name and problem first. Okay, now you must be having, so 1 minute for you just need to look at your chat on Zoom and get those particular content which I just shared with you. Now I'm going to give you the slide. Sorry, not slide, the URL. And I'll hope that few of you will able to do something here. Let's see. I will not able to take any questions till the time I see people actually is getting updating this particular thing. Unless no one is able to, then I'll chip in. You have to click on a link. You have to copy paste the content, and you can write your name so that you can find it afterward. And Deepali, can you do a sample testing for me?
Yeah, I'm also doing it.
Oh, take your time. All of you take your time. You don't need to hurry. And there is an edit also we can do quite often after that. So take your time. And this time is specifically reserved. And intent is to see through what you're going through design engineering, whether you populate for your own problem based on the learning what we have and how much it could be, right? So we will wait for some time more. Those who will not able to do Padlet because of any technical issues or anything, it's okay. Pen and pencil, pencil and paper, pen on paper would sufficient. One page, adding this your name, the problem what you're only the name what you need to add now currently, so that you can identify your own wall. And there is a edit button here. You can edit always whenever you want to edit your stuff. Um, so first thing you need to do is to add your name. The way I'm going to add my name. You don't need to add anything more than the name at this time. You need to copy this structure the way Canyon Tracer has done in your Padlet. So that will be easy for you to update it. Yeah, Arun also did right thing. And take your time because it's only one time. And you don't need to add anything more than problem. Sorry, name and problem probably. And if I mean, for a moment, I just want to start with name so that I can see at least people are there kind of a thing, right? Okay. So, Dipali, I'll just check with you if you are able to, and then we can move. Okay, those who will be on mobile, yes, of course, it will be difficult, so it's okay. You can hear me. That's not an issue at all. But why I'm asking you to put in, the more the better for you because you yourself will solve your problem in a decision point of view going forward. Yeah, I think that many things are coming up. So I think we'll only wait for a minute and then we'll start with our slides. And there are few people still adding, so it's okay. Push it whatever you have currently. We will anyway have time to put. Okay. So I think then now we will start. And those who and we will have a kind of stopgap arrangement in between. So even if you not able to do now, we will do it. You can do it later also. So no worries. I'm going back to the the slides. Now, what we just discussed a few minutes before is about a decision engineering. What we discussed also saying that, it's very important. And what would be your, I just thought to create one sample Padlet for you. Let's an example, Mastercard. Uh, Mastercard wanted to create a kind of a fraud detection decision engine. And their problem and outcome is like this, right? So approve only the genuine transactions and then block fraud and reduce the false declines kind of, right? So that's an outcome what you're looking at and the problem what you're solving. Signal and data for the credit card, they always want to capture the amount, merchant, time, location, device, history, right? So there's a very typical way the fraud can be detected, right? And that's why they added, let's say an example, this few things. Context point of view, how exactly, for them, a structure point of view that whether the device can be trusted or is there a way to find algorithm to trusted device or not, right? Or isn't kind of unusual customer, right? So that's something is very important when their model runs. And what model actually they would build and you also build for yourself probably is like fraud risk score or anomaly or keep clear boundaries kind of a thing, right? Uh, Decision ultimately approve, verify, decline, policy constraint and everything. Action is or decline, what it, right? And then feedback always important in any of the AI that whatever you've done to till action, from signal to action, whether what you did is right or not. And if it is not, then next time the algorithm has to take into considerations of whether you've done it right or wrong, right? So that's an example just for you to make sure that you understand what those few things in a Padlet on your own mindset of decision engineering, because these are the few fundamental of decision engineering where you need to filling yourself as an engineering and the human point of view before you do any kind of a system design of decisions. Now I'll move to the core part of it. See, the first thing is about decision value, right? We all know GenAI value. We all know GenAI value in the form of, oh, I can create an agent. You can then now, last 2 3 years of your own learning, you understood, oh, okay, if I create an agent, I can increase the productivity, I can increase the efficiency, and so and so, right? That's the way that your GenAI value you understood so far, right? But what is decision value? What if I able to make system decision right, like the way Mastercard did, let's say 98% right, and I can then reduce the fraud. I can actually the top up that will be a top line also as well as the bottom line and then the growth of the customer because of the trust, right? So that is so if the way you understood the GenAI with an agent, now what is the decision which is the next level of AI would be, right? So what is the value of it? So let's now understand the value and why it is important for all of you kind of thing, right? Then the overall, if you really see how exactly the decision value is now becoming in forefront, right? And these are the few example as I mentioned to you that those who are taking a good decisions or decision architecture or decision engineering, their values also increase, right? Now, Google once upon time was a search engine, right? And they earn their particular value because of the retrieve model, which is finding the relevant information and giving you a kind of links and let human decide. Right, that's what the way the model was in Google search for till the time the Perplexity come in picture, right? What Perplexity did is not about Gen AI. It's not about model they use. What they did that fundamentally they actually instead of retrieve only they synthesizer also. They build an answer also, right? They're not only given a relevant information and this time human verifies, not decide, right? So they increase the decision value by 2 notch than the Google, and they're able to make it what they are today, right? So they're like a 20 billion in terms of the market value or the number of users, and then they have their own browsers and competing with Google, and then so and so, and then the ecosystem is growing at different levels. So that's okay. End of it, what I would like you to convey is that okay, how it's important, right? The decision, if you change the decision engineering of any of the work what you're doing for your client, how much of glad he will be, right? I want you to see this perspective in that way. Mastercard is actually little more, they've done a fantastic job in terms of decision engineering per se. They are the pure decision engineering. I mean, Perplexity I given for one reason, but real decision engineering what they're because they scan almost all 150 billion record, right, for every transaction and convert into a decision with the 50 millisecond, right? So it's a very difficult engineering, and they're using RNN, they're using transformer, they're also using their own proprietary and all this, right? But intent is not going detailed technological. We are going to go anyway in detailed technological understanding of it. But intent to convey is that, okay, that kind of decision engineers you will see in future, right? Probably someone who can do better decision engineering using the Mastercard for a Perplexity, there'll be a Perplexity 2. Some other company will be even better than Google and Perplexity, probably, right? There is an experience built in the last, which is what my 2017 paper, which I filed, kind of thing. And I still feel that it solved many problems, because what I solved there is that is not only human decide, verify, but actually can human and AI co-decides the decisions together. And that is really required in kind of a human AI design on front end, and then create an experience journey maps for the retail users and everything. So which we are going to go in detail also, kind of. But what I want to convey here is that look at this, what we are talking about, right? We were thinking of the Perplexity as the top. So far, so good, taken over on Google, but that's not the case, right? So there is a more decision engineering and decision engineering led AI native companies going to come, and we need to know what exactly they're doing it differently, and and you all should know how exactly you can do it differently and what the decision engine underneath what required, kind of a thing, right? Now let me see if my screen is frozen or not. No. Look at the stack now. This is just information for you. As the decision complexity is going to increase, as when you reach to your customer, when you're going to talk to your customer, when you're going to solve the decision problem, the stack also is going to get a little complex, not necessarily every time, but look at the different components. I want to educate this first time. Google, all of you know, it was just in kind of their proprietary rank algorithm, and then there is a text, and then there is an NLP, right? I mean, very, very underestimating Google. I'm sorry for that. I don't mean it. What I mean to say is that the way the links were getting pushed into the Google search with first 20 and 10, and then we need to find out an answer from it. That was the way that it was working. Of course, they are now recently changed everything, and you must be seeing the difference, kind of thing, because they are also using the GenAI. But the stack was like that. But what was the stack for the Perplexity? Because the decision has been increased, and not just in GenAI. Now we are seeing that they added the GenAI model and having their own particular algorithm, right? So there is one small addition. Of course, it converted into some $2 from $1, right? When the Mastercard did, they got a little more rigorous. And why I'm taking Mastercard, do it not look as big as Perplexity? I still want you to get educated on this part, because it's not about a Perplexity or Google. Mastercard representing the enterprise use case. Enterprise are the one, as I mentioned a few minutes before, every AI company, including Claude, including OpenAI, including Mistral, you must be seeing all the traction last 1 week or 1.5 weeks or 2 weeks. Even it's going toward enterprises, right? And that is where the two things happening at the same time, which is what we are going. This hot topic of what we're talking today is one is how AI is getting on enterprise, and second thing, what the new technological stack they're going to involve or evolve into, kind of thing, right? This is what that's why it represents Mastercard that, right? So what is that? It has something new. So first thing, it doesn't have a text; it has a structured data. Okay, and what the previous AI is all together, and GenAI, everything is text driven, right? But this is a very structured data, and that's what the way the enterprise work, and that's the way it's going to be in future also. It has an ontology, it has a knowledge graph, it has its own different proprietary model for finding the fraud, right? It also now they added the GenAI, and more importantly, they also have a feedback. Now you will see the difference of how the decision when you are being tasked to do this, how exactly the different components are going to get added, or rather the different stack is going to get added. Now, experience builder, I'll add something more which I did. You may not be able to relate it completely, but for a moment, I added the events. I added the Kafka. I added the Flink. Many of you heard about this Kafka. Many of you heard about Flink. It's all the real-time event decision engines, which is specifically no one can replace them. No RDBMS, no vector, no graph, right? They are built for, because the way the future of an AI is all about real-time intelligence. And that's what I was figuring out when I was doing this experience builder, to create a kind of a very intuitive journey maps for a customer, so that before he even act on any button, he will get a kind of input what will react or not kind of thing, right? But events is something which is new. Or you can also see one thing more additional there. One is called human AI design, and second is called context. We will talk about it later. Okay. Intent to convey all of you, hey, this is what new world, this is what the new things you're going to go beyond in GenAI. And I just want you to be aware of it. 2 hours is not sufficient to go through all. Intent is to make you learn, right? Intent is to make you see the world, where it is going towards. Intent to see where the value in your career and where you're, so that you can read something better on this whole thing. Now I'll move to the next. I think I'm going to walk you through very quickly on Google, Perplexity, Mastercard, and then Experience Builder very quickly, because intent is, because I think the previous slide would have given you very good understanding of it. But my worry or my intent is that whether you will be able to add the outcome problem and outcome kind of a thing in your Padlet or not, right? Because I just want to capture your particular problem and what the outcome you're looking at this time. Okay, the way Perplexity did their own, the way Mastercard did their own and all, whether you will able to do that. And that's why I'm just giving few very high level example. Okay. We know all this thing. We know everyone. We know now this, what exactly it means. We know why we are doing it. Good. Now what we are going to do is we will now go to, if at all I had to give if Google in this class, what they would have added, right? As a part of Padlet, they would have added these things, right? And you're also going to do similar things. So you're going to add your own problem. You're going to find your own raw evidences. You're going to find your own context and meaning. You're going to say that, hey, I'm going to create a model for this one like this, and this is my boundaries. You also say that, okay, the decision point of view, this is what my decisions I'm going to take. This is what my actions I'm going to take through my AI system, and this is not feedback, right? So Google did their own retrieve model like this. If you, sorry for, I'm not able to click because there are a lot of pop-up. Okay. Perplexity did their own, Mastercard did their own, and I did my own, right? Um, as long as, as long as we able, I mean, I may not able to go on all, but as long as we know that there are Google has started with, I'll just give one example. Let's say their decision policy, the block 5, when they designed and when you design, right? That's really what differs, what you decide to design what, right? So when they design, they say that, okay, let me rank the result and a snippet. But when Perplexity did, they said that, okay, let me not rank the page, let me choose the source. Now the decision itself has different source altogether. When Mastercard take a decisions, they say that let me check it out the rules. Okay, using threshold rules. So again the definition has changed. And when I did myself, is I was trying to say that whether the how the human choices or human AI choices will ultimately lead to a right decision, kind of, right? So the way you change your decisions, thinking or decision engineering kind of thing, your architecture, as we said in this slide, your architecture is going to change. The way your solution you're going to come out with change. It will not be the same GenAI agent kind of thing. It will be something more highly differentiating decision algorithm which you're going to create. And that's why you will be differentiating market also, right? So intent of this few example, just to let you know that when you're going to feel, try to think before you add anything. And if it's okay, you still have a time to think afterward also. Now, what we'll do is that the takeaway for so far, before we go to Padlet and put your first thing, which is what the problem and what the outcome, only these two. What is the outcome? What is the takeaway for this? The level of machine decision authority changes the architecture of intelligence, right? Whether you build a kind of an agent or whether you build really decision apps, it's completely depend on what the problem you choose or what the future you choose for your company or whatever, right? Uh, and I really saw in my career and as well as in my student whom I work on various levels, right? I work with an engineering student through IIT Roorkee and other, and as well as a very CTO level kind of people who are mastered in their particular art. But I've seen that there are people who always think that, okay, let me solve if the problem is given to solve, how can I reduce the number of tickets? A one person think that let me reduce the number of ticket using algorithm. But the other person who said that why the ticket has to arrive at all? Can I do some algorithm which will never allow, rather the ticket should not even come into the system? Let me kill the root cause itself, right? So those people are actually eliminating the category itself. So you can imagine these two different people, two different the way take a call. Their output also different, their architecture different, their entire GenAI configuration always, because GenAI is just in technology, right? What you choose a problem is what the economic value what you're going to get out of it, right? Same thing in your career, same thing in what you do in your life, and same thing you do in your when you design and build kind of thing. So that's an important message which I want to leave with. And that's why this design engine required a human judgment. That's what the way the word is all about. And that's a part of a system design part one. What we'll do now is that we will now go to Padlet, and I suggest you only just add for a moment for me. Do me a favor. Just add what the problem you are solving and outcome which you want to do, and take your time. And only thing that we will have only 2-3 minutes, and we will just move on. This problem what you're solving and what the outcome you're looking. Mastercard said the problem is solving the fraud detection. Outcome looking at the less declines of false positive cases or less fraud, something like that. And it's okay whatever you add, right? Because that's that's a basic thing what we generally do as a part of system design. What the problem you're solving and what the outcome will be. Okay. Anyone has updated by chance? I've seen few. Yeah, I've seen solving. Oh, okay, very nice. Okay, wow, very nice. I'm seeing that you are solving. Yes, I can see that. Very nice. Francisco and someone anonymous actually done a good job in terms of explaining what it is. Thank you. Thank you very much. And I think there are a few additional there. I think that's so good. I'm seeing it, that whole thing. Let's an example, decision policy, schedule of prevent. Oh, very nice. Okay, understood. Understood. So there are few updates are happening, which is good for us. Okay. But because it's a time, let's say, what is it? It's 11:50, right? So we are in time, but I just want to rush through how exactly you're going to engineering part of it, right? So what are the solutions around it? I'm going back to my slides. Uh, and it's okay, as I said, if as long as all of you happy with what you're learning is okay. I'm showing my slides. Okay. Now, The question remains for all of us is that how you design the decisions. I think we understood the value, we understood the economic value, we understood the importance of it. So far, so good. Fine, fantastic. Thank you. What could be the what could be the way you started designing a whole thing? We also understood that we are not developing in GenAI. We are not also developing same agent kind of a thing. We are saying something different. We don't know what, but we are doing something different is what we decided. Okay. Now, how your act two is always about how you do the design, right? Now, the decision is all about the evidence what you bring, the decision policy which you enforce, the action what you take, and feedback of that action you take, and you collaborate with human to make sure that you work together to share the decision engine what human has, sharing with the machine, so that there'll be a kind of a 10 rounds of how exactly I taken decisions on various situation of rod X, Y, Z, Z, A, B, C, W, what it may be based on what I've seen, is what you're sharing that, right? So the decision actually you're going to share with the machine. And don't worry about whether you do that, it'll whether the machine will take over your job or not. No, it will not. The reason being is that I just want to give an answer to all of you is that even if you share your design engineering to the machine, it will not take away your job. Rather, you will find a new problem to solve, which we are not solved so far. And there are almost 80% of the things which we are not solved. What we are doing it so far in the human history is only doing an automation. 80% are still having a pain in their life, still having pain in process, pain in what we do always. So that 80% still not it, and that's that 80% required human judgment, right? So you don't really worry about these jobs and all this stuff, right? So clearly it's going to be take us on a very different level. We should be happy about what happening today. We should be really blessed that what happened is happened. And the thanks to all of them who have actually put an effort to make it happen, right? So just be in that phase. The only thing what you have been challenged now is that whether you learn something better, whether you want to go beyond what has been, you know from last 30 years. Okay, coming back to the main topic, the decision life cycle, which was not been explored so far by a machine, not been explored by our human person, is that whether we really bring an evidence properly, because what we do is, and today is a very raw data, right? With a kind of structured data, and some other vector is now started coming in altogether. But we don't enforce on decision policies also, right? Today, in general, right? So decision is all about how you enforce that, how you take an actions based on the policy, how the feedback you capture for that what you've done, and how exactly human action. So all this is the anatomy of what I would call for it, right? And it's not what I want to convey in this slide is that it does not exist today in the way we design the things. Okay, we don't do all this thing, right? What we do in agent, if you really me ask me, is what agent actually does only one thing is that take a tool, run it through for the goal. It's a goal to tool to action. Goal to tool to action, right? That's what it reaches to, right? It doesn't do any feedback. Okay, it doesn't do any kind of a very discerning on the policy altogether, because it's not been there is no block at this time exist in solar architecture, which is fine, right? Um, the once you understand anatomy, the other thing which I just want you to know, little heavy slide, just hear and forget. Don't worry. Previous slide is very important. What decision anatomy look like? This slide is to tell you that these are all the different dimensions of a decisions model we are going to play. Some of them we already playing, and some of them we are going to play. And I just want, and some of these particular models we are going to play along with GenAI, which was earlier used to be in machine learning and those things. But now going forward, it's a combination of. So you will see this model, what exists today also will be played differently. And that's what I want you to get educated on that. What are this? Now look at this water. So predictive model, all of you know. And the second one, the causal models, which is the what if I intervene. Optimization, which action best fit for the constraint, right? Rules, what is allowed and what is prohibited. That something is again the model, right? The decision model is what you're talking about, how input and rules and outcomes connected. So a decision engineering point of view, one is what are the different way you dissect the problem and ensure that all these things are being taken care as a part of your designs. And that's what the design engineering of a decision or system design of decision engineering is much more than a GenAI. And this is what an example for all of you, right? Can any of this block can be done through a Claude or GenAI or any of the model with the small, large, medium? Answer is yes, which was not previously possible. And that is where the option for us to really get into a different world, which was not exist kind of thing, right? What I'm giving you an idea so far so good is I give you an idea about anatomy, some new elements, new colors. What are the model, what we have seen before is the same, but how they will change. And you need to know what the question you need to ask yourself during a design of a system, design engineering. Now, this is just an example that prediction ultimately what we have done so far. The prediction is something what we are doing for ages, right? And the model, if it all gives an output or your previous model has given outputs, an 80% probability of a default, right? But actually taking a decision, this 18% probability default is not sufficient. It actually required, the objective, alternative, policies, action, feedback. And when you do a combination of all these things, you'll actually create a very good, you go beyond, the prediction kind of thing, right? And that's what the way decision engineering involves. And that's what these all elements are important. Whether the problem and the outcome, what I just mentioned, right? And the intent of that exercise is only that whether you can add all these one by one blocks, action, policy, feedback in your design, and if that actually is going to help you or not. Now, how the decisions generally happen in the machine going forward, and as well as Mastercard and all this thing is what this is called a loop. This is what the way the loop happens. Okay. And this is what the way the architecture revolves around it, kind of thing. So it actually, this loop is just to give an idea, very high level. It could be new for you, it could be known to you, it doesn't matter, but it's something new in terms of when the Mastercard written the whole algorithm, right? So it actually check it out the objective. It actually check out what evidence from the 150 billion, which has been already happened, right? It check out the models. Can I infer whether this is fraud or not? Can I then it apply the policy, right? And ultimately, when it comes to decisions, it actually then figure out the risk engine, whatever they created. That's a risk engine, their algorithm. Risk engine is their particular USP, which actually ensure that the classification of whether this side or that side or whichever it may be, right? But and finally, of course, an action, and it goes on always in loop and every time, right? All this 150 billion become 250 billion going forward, and then they will keep involving in this whole this complete decision loop continuously in their whole the pipeline whatever they built, right? What I'm showing you here is that just to tell you what the process of a decision loops look like. Okay. Now, important thing is that if you're an architect, and this is very important, I just want you to little give more attention. If you're an architect going forward on intelligence, usually we ask a question about the data and then context and then all this thing, right? But actually, the people who are actually good architect, right? They actually start with an outcome. And as I mentioned about a few minutes before, right? So what is an outcome you're looking at? Whether you want to reduce the tickets or whether you want to eliminate the tickets, right? Because an entire design will become a decision engine or become a kind of an agent engine. It's all decision on that part, right? So if you decide an outcome, your action also you change. When you create an action space in an AI, when you create an actions design in your particular architecture, uh, which will know what to change the world for that outcome, right? Or what I need to change the world for that outcome is also change. Then the choices what you taken for the decision point is also change, and of course your context also change. Now this is very important. Context is something all of you know is the context engineering, the word what all of you must have heard of it, right? But actually before that, if you do a design better or the decision better, then your context engineering is also better. Why? Because rather going in, there will be a slide for it also. But let me give an idea about it. So all of you heard about context engineering. All of you know that context engineering is in kind of a front ending, the skills. All of you know that context is nothing but that data which I send as a context to a model. And if I have been precise in sending that particular context or in that data, instead of sending a book or a gigabyte, if I precisely send for the query, model will able to reason it fantastic. And then my customer who's actually looking for a query, he will get a right answer. And that is what the context engineering today, right? And that's what we've been trained in the context engineering in also in our current work. But if you're able to decide the decisioning part of it and what the problem you're solving and what action you want to take, I think your context automatically get refined. Rather, the context will give an input and decision very well, right? So I just want you to be a little more thinking forward point of view, saying that, okay, you just need to do in context engineering, but if you're deciding outcome and action and decisions, your context engineering will certainly become more better and different. Because here is the last statement. What is the minimum reliable context required for the decision? As long as you arrive that, automatically your accuracy, reliability of the AI system, what you're building, is going to get increased. I repeat, if you're able to find what is the reliable context required for the decision or the moment of decision, and what happened currently today's world with most of people when I misunderstood the context engineering is that they don't think a decision as an outcome. They only think that the task is an action, goal is an action. That's not correct. The user at the end, as I mentioned in previous slides, they're looking for a decision. They're not looking for an action. You can take 10 actions, but which action will help to take a decision is what all about the future of an AI, right? So the slide will help you out understanding the importance of where the transition is going to happen from context engineering to design engineering. Hopefully, it will help. Had it been given to me, I would have actually talked to you in detail about it, but because of the time and because of the things we need to, as long as we understand this for a moment, fine. But this is very important from the future point of view. I'll move to the next. Now I'll skip this. What is that we learn from so far so good? Is nothing but that the future going forward, right? So when you're doing context engineering and we want to move to the decision engineering, you'll now need to do a kind of an evidence. You need to have an objective, alternatives, policy, constraint, and all this, right? So you are now talking about something different than what you've been talking so long in the last 3 years. And that's very important takeaway for all of you. And as I explain you why your context can not be better unless you not take a decision, is the reason is that because economics in future is about whether you deliver the intelligence per token. The deliver the per intelligence token required whether you make some decision for someone, and that too also right decision. People will pay you for right decision, right? And that's what the economy is going to play. And that's why the context need to be designed based on the decision rather than the action, because action can be anything. As I said, I would explain you very, very differently. Hopefully you understood the very subtle but very powerful change what we're going to observe in future of an enterprise and future of an AI. Had it, okay, so if you'd had kind of a 4 hours, I would have asked you to, put your decisions, action, and feedback. It would have been really fun. You yourself seeing how you're going to change your architecture, how you're actually designing the whole system differently than what used to be, kind of, right? But given that limitation, I will avoid that. hold on. Let me, how can I? Okay. Um, okay. So it's 12:06. So 1 hour, 5 minutes has gone, almost 1 hour crossed. I think we are in good shape. In a way, we captured almost all 50% of the content what we supposed to, because total there are only 50 slides. We already on 24 slides, so we are good. So we are in perfect moment of what we're supposed to. Now, before I go forward, just want to check it out how many. Okay, 82 people. Very good. I think we have enough. Now, I just want all of you to give me a sense whether you're getting what I'm saying. By thumbs up, by anything on a Zoom you can do for me. If you can do me a favor, please. Or I can pick few, not an issue. Anyone who wish to, okay, Anand Banerjee, or anyone who can actually just give me a sense of it, that whether you understood so far so good what I just mentioned. Okay, there's thumbs up coming in. Arun or Ashik or Bert, anyone? Okay, is it mute for all or something like that by chance? No, right?
Yes, they can't unmute themselves, but
Oh, I'm so sorry. I'm so sorry.
I'm giving them the permission to unmute themselves. Like they can raise the hand and I can unmute them.
Okay, okay. If anyone want to raise their hand and just convey what they learned so far, whether they understood what I mean talked so far. I think someone has raised thumbs up. Anyone raise the hand? Okay, even that facility is not. I don't know. Dipali, if it is not allowed, then it's okay. We will still go ahead. Is it okay?
Yes, sir, we can go ahead. Most of them have put in the chat box that they understood
Are
and
you? I'm so miss. Okay, I'm so sorry. I not checked out the chat, but okay, very nice. Okay, so I generally want to take this in between kind of a thing. The reason being is since the subject is new but very important for all of you. That's why. Okay. Now the main important is in architecture, right? So if you make the decision engineering the way I said before, specifically what the data architecture and the model capabilities is what you need to know to convert your reasoning into a decisioning. I repeat, what are the data architecture and model capabilities will able to now you take it forward for your decision engineering. And that's why I'm saying architecture follows the decisions. Okay. Uh, so just to give you a very good understanding of it, an architecture point of view, all of you know that left hand side, little verbose slide, but I will go slow. See, we have a raw signals in the form of very unstructured data. We have a kind of a table rows, which is a little structure, which only tells you what happened. Then we have now arrived with the vectors and an embedding, which actually given kind of a how similar are those particular the information which we were not able to find out through a table and rows, which all of you know, which is called the cosine similarity between the information, which used to be missed, but now we have started getting in. Then the freshness and the state change, which is statefulness, we call, right? So statefulness is very important, and context is all about that. Context is all about the statefulness and maintaining only that state what required, and exactly provide that information when real time as well as uh, what meaningful both, right? The graphs are completely a relationship database. Those are all now coming in, right? Which will ultimately will help you to ensure that whatever the problem with other data structures, right, which is ultimately vectors and embedding, all of you know that it's find a similar, it is not exactly what it's supposed to be as per the business rules point of view, right? So example could be is that you cannot say, I mean, in enterprise architecture, right? So you need to be very clear about a relationship between the entities. And if you give an underwriting go ahead for one of the loan approval, and if your ontologies for the underwriting is taken by a semantic way of thing, you will approve hundreds of loan without even doing it, kind of, right? So graph which has not been currently used, ontology what is not been currently used in AI, that is the new where the decision engineering is going to change for betterment, all right? So what happening in data structure point of view, you must be seeing the intelligence level is increasing in 1, 2, 3, 4, 5, 6 kind of a thing. And finally, we're going to arrive at the context, which is the decision ready. Currently, the context engineering is not the action ready. What we're saying, the context will be a decision ready. That's the lift part of it. I would just want you to know the architecture point of view, what happening, and the elements which you need to add point of view, right? On the data point of view. Model point of view, if you really see where we are, we know that sequence model meant to say a serial way of doing the NLP was the RNN once upon a time. Very serial way of doing it, right? And that's why we never scaled up. But when the transformer came, it became a parallel processing. That's why you're seeing what in the 2021 onward happened is because of that actually the parallel processing of an NLP. Okay. And of course, attention logic is what made it intelligent also. But the fundamental difference from the model capability point of view is the transformer unlock, right? The second part is the generative AI. I mean to say, it's generative AI is not about only just the text is getting created or on generated kind of thing. It's about a transfer learning also, right? I mean to say, if you given kind of a few short prompt, model started learning on their own. So that was not been thought before. It was only just generative creating a text, but now as a side effect you can think of, and as a kind of part of the model architectures you can think of, it's become a level to the next level of intelligence, not only just a language, but language with the skills. That is called in context learning. We are now into a reasoning to a planning. We are not it still cross the planning. Models are reasoning, but they're still not doing the reasoning they're supposed to be. The reason being is that, and this is very important for all of you to know, this is the constraint which you need to know, because reasoning is still not at there where it's supposed to be, because it's only a text based of finding the probabilities of, what, whether the accident happen or not happen, or whether the underwriting to be done or not to be done, kind of thing, right? It doesn't have the real business knowledge. It has only a text knowledge, and text knowledge is not the business knowledge, and business knowledge is the only thing which can take the decision, right? And that's why unless you'll not have a planning, unless you'll not have a decisioning engine added into the AI, right, you're not able to come to a decisioning, right? What this thing is telling you, why this I create, why I have created this particular slides for you, because there are, in your decision engine, when you're going to do, you have to choose your data structure, you have to choose your model structure, and you have to always reach to and see through that whether you can reach to a context which is a decision ready, right? That is what the overall the structure is all about. Okay, these are the only two things what I would like you to remember for a moment. You don't need to remember anything more than that. Now, GenAI and agent was not taking care of all this thing in all aspects. They are not taking care of graphs, ontologies. So far, they will certainly, of course, right? And but they are not still so far. The reason, because that's the way we've been talking about it, right? Now, why this slide is also important for you? Because it's a token economy. In the last bottom below, you see there is a, see the way what you will be in future, what you will be called for is not for building an agent. You'll be called only for whether you deliver the intelligence or not. As simple as it could be, right? Your agent can be done by even the machine also going forward. But whether you're able to engineer the decisioning in such a way that it will create the tokens which is going to generate are really in kind of decision making tokens. And if you are having specific way of doing that thing, different way of doing the things, you'll be paid more. Not like you come for an agent building and so on, right? And that's why the right hand side career opportunity for you is that whether you really yourself scaled for data, context, constraint, reliability, and feedback, right? So these are the few, whether you do in constraint engineering, right? Why constraint engineering? I'm just taking one for information, but not all. Constraint means GenAI has almost all 6 constraint. Example, it hallucinate. Hallucinate is a constraint, but it's also a powerful mechanism how you can convert hallucination into something different, right? Or reasoning. It doesn't reason at this time today, but appear to be in decision. So can you convert that appearing decisioning in reasoning into a decisioning, right? How to do that? Will you able to create some few components out of it? So you should know the overall that constraint definition. Same thing in your reliability, feedback, and so on. So, but I'm just giving an idea that your skills and your career is all about, on the left hand side to manage the new ways of doing decision, and the right hand side the way you understand to make the decisions out with using all these 4 or 5 things, and you master those. So you may not, your previous skills are very important anyway. Let's say a few people in this group who are doing this master in their data, or who've been part of data lakes and data apps creation and everything, and few of you are from agent kind of thing. The skill is really important what you mean, but the next level is what you need to reach to, which is called a decision engineering. That is what you will learn, the input of this. Now, data structure point of view, I'm just going to help you in terms of few judgment. And I think it will help you also. When you're going to decide your decision engineering stack, and the way I did decision engineering stack for myself, right? I added event graph very heavily in my 2017 product which I built. Same thing Perplexity did, same thing Mastercard did, right? So if you change the data structure, you change the intelligence is what the message is. Are you doing vector way of doing it today? Yes, you are doing it anyway. But when you change your decision engineering, you certainly want to have a kind of a state change or the freshness. These are the two things which will make the decision. All of you would know or will know that in every evolution of a technology, means to say the previously without internet, now with AI, right? What is changing? The most important changing is about the way the decision is getting taken on the real-time basis. It's a speed has changed. It is a velocity has changed very much, right? And every business is into that space kind of thing, right? Those who are going to make it fast, those are going to make it real, those are going to make it quick, are the people who are going to get that particular loan, or the person, or what it, right? So irrespective of, invariably what is going to happen is that the most of future decisions is in an event and stream. So you need to know a Flink, you need to know Kafka, you need to know the architecture behind it, because that cannot be replaced by GenAI. That cannot be replaced by vector. And what we are seeing today, an app like in kind of Uber, which are an event driven, which is like in kind of any of these the quick commerce, whatever in India currently, right? Where you can get your groceries in 5 minutes, 10 minutes, and so on, tracking everything, right? Those are all specifically in event driven, right? And why? That's what the way I'm saying that the real-time business has actually challenged the existing, Amazon business. Amazon was in kind of an offline business, right? But a quick commerce, which is delivering in 10 minutes, 15 minutes, actually change the way the business model is, because the business is changing, and that's why you need to adapt to this particular new technological thing, right? Technical advancement, what you're doing. So now this is existing so many years, right? So an event and then Flink and then Kafka don't exist today, right? From last probably 30 years. The important thing is that now you need to have that skill and every person has to have that skill very much going forward, because a decision engineering or the decision economy is going to be on that. Important thing is graph and ontology and architecture point of view, as I mentioned before, and as well as now I'm repeating, because I just want to make sure that your outcome has to change in that. What matters at the end of day for business and enterprises is the reliability. What is graph is what we're going to talk in future also. I'm going to explain a little bit more what graph look like, those who don't know. But the relationship between these entities in business, ultimately what matters is that if I'm taking a loan for an asset underline, and asset underline has a kind of a risk underline, and a risk underline has a kind of a repercussions from the liability point of view. If this particular entire domain understanding of what it means and the risk behind it kind of thing, if you don't put into your new apps, whether it's a GenAI app or it's a, you won't be able to make any difference, right? So it doesn't matter whether you're a lake house, whether you're kind of an expertise in your things, but unless until you not convert yourself into graph and ontologies way, you unlikely to reach to a kind of a decision engineering. Now, that's ultimately finally come to a decision or a ready context. So this is what a brief about a judgment. So you need to take a judgment, as I said. I'll skip this for a moment, but judgment also for the model, as all of I told you that you need to, the important thing for in decision engineering, you know that models today generates, they can reason probably, not necessarily reasoning. They appear to be reasoning, but you ultimately need to go the last stage, which is called decide. So now how you change then reasoning to plan and decide, something in engineering you need to do on top of them. You need to figure out the way in engineering on top of them to make it plan and decide kind of thing, with the action feedback loop, the way what putting a decent policies and so kind of thing, right? So this is what the model. So judgment one is about data structure, judgment two is about model and their particular boundaries. You should know both. Art of possible in data structure, art of possible and not possible in model. If you know, you will able to design your decision engineering very well. Okay, that's what the whole the thing, right? Now, just to give a kind of a model reasoning point of view, the models still today are not reached to a kind of a very feedback, whether they understand the feedback or not, whether they understand the policies or not, whether they understand an objective for an optimization or not, right? Because they're all the very physical business entities all about, or whether they know that human checkpoint, or that whether they can actually do validate the things deterministically. They are probabilistic models, right? So can they validate something which is what not they've been born for, right? Now you need to know the models currently before they use it, that how can you actually be aware of all this thing which is required for decision engineering in future, and how you can actually make sure that they actually, you still need to use it, right? So the way Mastercard use it, they use it, right? The question remains is that whether you, this slide is to tell you that, hey, these are the decision engineering three aspect, four aspect, 1, 2, 3, 4, what you're saying. Model still not there, so you need to be very clear about it. What I'm explaining you, the judgment point of view, engineering point of view, what model can do, what model cannot do. That's only intent. What is that final takeaway for the slides, what we will run through? If, as an architect, even if you select the smallest architecture from all this data structure and model architecture, even if you take a smallest one, right? You'll improve the decision quality. So your focus should be going forward, not anything else, but increase the decision quality. Your automatically your context engineering going to improve. You're actually the way you're going to design the system is going to change and everything so and so, right? And I think it's not only me going through in that way, right? It's an Anthropic also. All of you know recently what they've done, right? So they actually launched and they said that I will not do XYZ in my new model Fable, which is what they launched. They don't want to now get into that rat race of a competition and do something which is what going to hurt wrong decisions for the wrong people using wrong models with the wrong context with the wrong information kind of, right? So even my business get hampered, that's fine. I still don't want to go in wrong way. That's why the way you'll see that. And I think it's also reason because an IPO has to be gone. So OpenAI and both of them actually started now taking this seriously about how they're what they will do. Even the smallest part on architecture that will help a decision making rather than kind of a essay writing, they're fine with that, right? That's how the change is happening. And I just want you to be acknowledging this whole thing, that where the industry is going towards. Now, again, I would have Padlet, I would have gone you through this one. Now, what we're going to learn is a context engineering, a bit of it, what exactly it means to all of you. And how that is related to a decision engineering. Just a few examples so that some mental model difference between both of these two things, which is one is about to come, one is already in process, how the transitioning, so that you have a clear understanding of how the architecture is going to evolve, right? The Context engineering judgment point of view, as I mentioned earlier also, the instead of building a context only for an agent, you're actually now going to add more into that called features. Let's say the left hand side top, right? You're going to add few data from the business point of view, add the business meaning to it, right? You're going to add the state kind of a thing, right? So, or you're going to add the rules kind of thing, right? So what we are saying is that we are now reaching to a state where there is I'll show you an example that will be very important for you. Okay. Okay. So this is something is going to merge. Okay. So just let me give first a mental model. See, context build the evidence today. It don't take a decision, right? It build an evidence. Evidence means actually in the form of whatever the conversation which I had with the user, what is the question he started off with, what the objective which he had, what the action he want to take, right? What was the last 10 conversation out of which, how can I give a summary of it? What is the new conversation coming? So these are all the evidences which is gathering. That's context engineering is all about. Decision engineering actually turn this particular evidences into very choices and actions and a complete learning loop. That's a two different aspect of, right? So when you're going to architect your intelligence, you need both. What you learned so far is about only the context and finding out the summarization, finding out, there is episodic memory, then there is a kind of, the short memory, long memory, and so on. So what you're learning from everywhere and everywhere in the world, right? And the whole thing, right? In the agent architecture kind of, right? But those are already they're just an evidence building. They're not a decision making. So decision engineering is something which will turn into this choices and then action. That is where the real work is going to come to. That's a mental model for you before I go in detail. And that decision engineering ultimately required this all choice, action, feedback, policy, alternative, while the context engineering probably required only few, right? So this few slides just going to educate you about what are the additional thing which need to add. An example here is like what is allowed, what should be happen now, who and what to execute, and did it work, right? This is what we never configure in our context engineering. We don't need to really worry about all this stuff. We just need to make sure that the moment a loop run in agent, it has to come out either an error or it will come out as a kind of a success. It doesn't matter whether the policy was there, choices was made, or action has been taken. Only action is bothered about action, kind of, right? So that's what the big difference. Now, what did we learn from this context engineering and the decision? What are the differences between all together? Right, is only about two elements. So, what did we learn so far? We learn about decision engineering first, then we learn about what the architectural changes, which are the new stack coming in data and the model. What is that you need to worry, what not to worry about it. Then you learn about the context engineering and decision engineering. What are the new elements are going to come in, right? Had it been a Padlet, you would have added all this thing in your configurations, right? Now there is a context graph. Now this is something in kind of a solution, I would say, which will manage both the world together, which is on one side in the context, second is the graph. Graph represents probably decisions. And that's where the merging is going to happen. And that's where your new decision engineering, some sort of a new architecture, some sort of a new layers which you're going to evolve through. Okay. I'll take a quick now pause before I go because it's only few slides remaining. Dipali,
Yes.
is there a possibility that we can allow, because we have a good time now,
Mm-hmm.
and we have enough to coverage kind of a thing? Is it allowed to allow people to ask you any questions?
Yeah, yeah, we can take it.
Okay. So do you want to open up, unmute themselves?
So I would request participant if they can raise your hand or put it in the chat box so I can give them the access to unmute. themselves. So
Probably
anyone has any questions can just raise their hand or put it in the chat box.
I suggest if you allow them to, unmute all for a moment.
Sure, sure. I can give that access.
It's a good amount of people. I mean, good volume in terms of the people out there, right? So there
Yeah.
must be something. Or
I
probably,
will just,
yeah, go ahead.
I'm sorry, I don't know how to raise my hand, and now you
I know,
just
I know.
said like unmute everyone, and I would go ahead and ask the
Please,
first
please go ahead.
question if it's okay.
Yeah.
Um, I'm quite excited because in the past I was concentrating on software architecture, which is very technical, and I had some barriers to bring to the table what was important to me in that field, in that IT surrounding. And now I'm following your content, and it's much about decision making and context engineering. And I recently found the field of cognition science, or cognition science in German, is called, where psychology and philosophy and informatics and AI all comes together. So my question would be, what you just taught us, where do you have sources to dig deeper into and to dive deeper into, like, how does a system make a good decision? What is a good decision in this case?
Very
Do you
nice.
have further readings in
Yes,
that
yes,
field?
yes. I do have. I can send you an offline about, and rather, okay, so here is input for you, Lisa. I don't know, this question is absolutely fantabulous. The reason I'm telling you because the largely we know that decision economy will be the largest economy in future. Okay. And we also know that making a good decision is not a, a very simple thing, right? Uh, and that too also making decisions with by machine, which is already cursed or blessed with the probabilistic modeling around it, right? So we are running a very difficult phase of transitioning to a new thing. As far as the answer to your question, the Gartner actually publish the all the companies who are working in decision intelligence, and I'll forward you as a part of. I'm just taking a note of it. So what this company is doing, whom Gartner currently rating, one is FICO, another one is Extra Data, one is all those names are there, very very different names, Sapiens, right? They are actually exactly what you're just talking about. There is a combination of social engineering, there is a combination of psychology engineering, and then there's a combination of the way the business decision is going to be made in the future, right? So these are all the combination. So what these people actually creating the algorithm is only on that. Okay, it's only on those particular aspects, and you will see that those things are those who will be in that field. Like, I think if you're in that field, I'll request you that the future thing what I'm going to share with you, if you go in detail, you actually can create your own decision engine algorithm, right, for an XYZ problem, what it could be, right? So I'll answer you in the form of few of the links based on the Gartners plus the companies, which is what actually into decision intelligence kind of thing. Does that help you, Lisa?
Yes, thank you.
Okay. Few more question, please.
Hi, Suchit.
Yeah, go ahead.
One of the problem I have, as you were saying, so we have our product employer transportation system, and in that we want to integrate that solution into the Zoho platform or something like AWS architecture. So how this system design, we have our current architecture on the VPS, so Docker and everything we are using. And so we want to design with the new architecture, basically the system design, which with the AI system, how we can start doing, how we can proceed with that.
Got it.
Any
So
guidance?
the guidance, the only one thing is that Rahul, if you can summarize, is that what have you heard so far? Is there anything applicable to you in what is the current situation you are into?
Uh, some of that, but I just want the guidance. The I heard about like decision, how we have to make the decision, right? Like you given an example where like the support ticket. I understood that
Very
example, the
nice.
Mastercard.
Very
So
nice.
yeah, all that
So,
decision
so
which
then fine. This is exactly what I'm looking at, whether you pick up those example on. So here's the thing. In your case also, whatever the problem you're solving, right? So let's say an example, whether you really want to solve the ticket problem or whether you eliminate the ticket, right? If you guys able to together, right? So just put those, if you have the slide which I'm going to share, right? And then if you put those, the objective alternatives, policies, choices, actions, and everything, if you come out with your own particular, this the problem convert your what is the problem you're saying, right, into any of this, all of this rather, right? I'm 100% sure you will start, that will give you kind of an idea about how exactly you shape up your architecture from data and then model, and then where you use what kind of a data, how exactly you'll use the model for it, how much you can use, how much you will not use, and you'll find a very minimalistic intelligence architecture for yourself. The technological thing what just mentioned, forget those. I mean, honestly, the whether it's a Zoho, whether it's an AWS, whether it doesn't matter, right? So actually those will come later, right? When you design the whole this, fundamental problem converting into something, a template which you want to convert into an architecture, if you're done with that, I think you'll be in better position to take up your solution. I'll take one more question and then I will complete the context graph, which is also very interesting. And I think that is where your solution may arrive also. Go ahead. Anyone else? No one?
I have given the access to unmute, like they can unmute themselves. So
Oh, yeah,
anyone
yeah.
have any questions?
Yeah. Anyone who want to ask question, please go ahead. Okay. So no issues. So I think what we can do is there are few people who are known to me. So I'll ask them. Mohan, you're there by chance?
Yes, sir. I was about to unmute.
So please let me know
Yeah,
whether
I have one
it's,
question.
yeah.
Just one question, sir. Initially, we were talking about architecture of intelligence, and you were talking about. Let me just look at my notes. So basically, my question is like, what are the various factors? Because we are talking about the machine decision authority, if I'm looking at my notes correctly. Is it just that, or what are the other factors we need to think of when we talk about architecture of intelligence?
Intelligence. Only
And
two things. Let me answer this question first.
Yeah.
The architect of intelligence, which is what I coined the whole word now, with my own particular thing, which I do always, right? AI with Suchit. The intent of that one is that you can, if at all, Mohan, if you solve two things, you really can become an architect of intelligence. So one is that whether you're able to create an evidence in the form of context, right?
Okay.
And whether you allow machine to take a decisions with a right, the decision policies, right?
Yeah.
So
Okay.
if the intelligence, what is an epitome of an intelligence is all about, I mean, for you, if at all Mohan, given with one agent or one particular, and he's taking a decision beyond behalf of Mohan, you'll be blessed, isn't it? The problem today you have, Mohan, is that you are not very confident about the decision what has been made, right? And we are not yet reached there, and which will be very difficult. That's what the way what we're talking about. That intelligence is up to epitome is ultimately whether you able or the machine is able to really do one kind of good right decision, and that's what the Lisa's question was. That what is it required to do a right decision? What is it behind it, kind of
Correct.
thing, right?
Correct.
And that is nothing but is that, of course, when I did the context, sorry, when I did, I'll tell you what I did. So when I did the experience builder, and that also goes to answering to Lisa's questions, right? So actually, when I built my own model of good decisioning definitions, right? So my biggest thing is about the human AI into that product, and then second was the feedback rather than anything else. Of course, I use the Kafka, I use the Neo4j as a graph and everything and so on. So, but biggest thing I'll tell you what the engineering which I did differently. So human AI means, can I allow a business user in experience creation and help him not only to drag and drop and create an experience journey for a retail customer, but also helped him that whether he can embed the decision rules and a process there and there itself when he's thinking. And
Yeah.
what I made machine to learn is that that particular graph of a human, when he create a graph of a process, right, can when he taken a few directions in that graph, whether why he taken that graph that way, and why he chose one branch against the other branch, right? So when I used to ask that questions to businesses, and when they used to take on different branches, that is where the human and machine collaboration happens,
Yeah.
where the decision has been changed, kind of thing, right? And then feedback,
Yeah.
whether the action
Yeah.
what I given for that branch is what exactly what is supposed. So those thinking is still not in an agent. Those thinking has not been done so far, and that's where the difference is going to come
Yeah.
for.
Yeah.
That will be an answer for your question
Just
too.
to add to Lisa's question as well, with
Yeah.
respect to how a decision is made. Of course, all the things that you talked about in terms of the context, everything matters. But the role of ontology, knowledge graph, and how it all comes together, that visualization also could be, it's like dissecting a decision,
Dissecting
how
it.
an LLM does it.
Yeah. How the
That
LLM
could
will
be
be.
interesting
That could be.
at
Yeah.
some point. Yeah.
That, yeah, because those are the people, those are the aspect which is talk about ontology. Those will get the physical world evidences to you, which
Yeah,
was not
rules,
existing.
exactly.
Right.
Real world rules.
Real
Correct.
world, yeah, real world rules, real world thing, which has not been so far trained by the AI so far, right? So those are the one which is the decision engineering start converting into it, right? So that's what the whole
Yeah.
thing.
Yeah.
Now I'll go to
And
yeah, go ahead, go ahead. Sure, sure, sure.
sorry, nothing, you can proceed with others. No problem.
No, I'll just complete then the context graph also.
Yeah.
So where the context graph is coming, right? So I think there is a very this is where the things are going to come in future, and this is where now is converging also anyway. Okay. So now why the graph is entering into the story is because if you see in the left hand side, which is a very disconnected evidences which we are giving to a machine today. And the same thing, right hand side, we are going to give now in future a very connected evidences to a machine. That's make a huge difference. Okay. The only problem with the machine today in the algorithm, what they have is that doesn't mean even if you give the right hand side connected meaning of a policy to a customer, to risk, to an outcome and all, right? What happened, I'll tell you. The graph is very well understand the relation between these two nodes, because these two nodes are connected with a kind of a numeric figures, and with also the relation that whether there is a risk relation between policy and transaction, or whether there is a customer happiness with customer and transaction, those relations and their numeric value is not been known to a machine. Okay. So what is going to happen in future, and what you need to actually make sure that machine understand that part, you need to actually do this context graph engineering in future, right? There is where the things going to come. It will come, of course, through our models going forward anyway. And there are so many Microsoft launch with the context RAG, or the RAG with the graph RAG kind of a thing. Many other graph RAG is coming in, or the RAG graph is coming in all the way and all together, right? And there is also a kind of a, but that doesn't mean that that will solve the problem, right? That will only help out that one of the issue with the decision engineering is a graph or relationship or an entity, and their proximity of taking decisions with this side of that order, right? So that is one thing, that is called in context graph, right? And then the decisions, as what Lisa asked, and otherwise also what you are referring to, all of you are referring to, right? The way a decision formula is going to work out is like this. There will be a possibility of what change if we intervene, which is a causal way of kind of, right? Or there isn't kind of a knowledge, I mean to say what are the entities and that meaning kind of thing, right? Or what is that, let's say, lineage, where this evidence come from, and a weightage. The decision is ultimately in the weightage, which is what today not known to model or an engineering of an or the AI system. There are the different type of, the weightage will get created or calculated on every use case going forward. And if those weightage are XYZ way of an algorithm point of view reaches to, the escalation as in decisions, or allow a fraud transaction as a false positive and then convert into a transactions, whatever, right? All these things come out. But dimension, if you really see, is very vast going forward. Let's say an example, as I said, the workflow is one aspect which was not been captured, the causal relationship or the knowledge relationship, right? So those are the one. So it's not a graph just in kind of a graph database, but a different set of graphs ultimately leading toward their weightage to create a kind of decisions, right? That is where the future is all about. You may or may not need to know all these things the moment you'll actually take a very good example of it, which will ultimately lead to this. But this is what the ontology ultimately is going to come to you, where you actually convert your graphs into, or ontologies help you define your ontology first and convert into the respective domain meaning and everything, and their thing. And then finally, and this is where the thing is going to happen, this is what the things are happening currently, right? So we are in two different world, and halfway through two different. So one is a vector where the semantical understanding of a world knowledge is getting represented, but not necessarily that world knowledge what vector is representing is the real world knowledge. It is just in semantically similar, the entity's understanding, right? Which will be now supported by the graph to increase the decision coefficient or decision weightage kind of a thing, right? So that's where the context engineering, what we are doing today, and versus the hybrid context, what we're going to do tomorrow, is going to be changing, right? That is where you need to apply your judgment, selecting a stack, selecting a component, creating your confidence score, writing if and else code, the writing the code for it, adding a human intervention in between. So that hybrid context is going to come out as a graph, or a context graph point of view, right? Now, if you see an architecture, if you ask me an architecture, the way I'm thinking is like this of a decision, or answering to Lisa's questions as well as in all of you, right? It will certainly have a time validity. It will have a current state. It will have a kind of a the confidence and policy relevance and situational, so and so and so and so on. It will have now going forward all these elements which are going to make a decision as a good decision kind of a thing. Okay, and that's what I need to add anyway. But what raw into a decision engine is going to happen is how you put these signals into a knowledge graph, into an ontology, and into a context graph, right? Ultimately, as I said, the facts in a distant context, right? So if you're able to create this whole new architecture and then making them action oriented and feedback oriented continuous loop, right? That context graph architecture is going to then change the way what we're doing in context engineering today, or in future it will be decision engineering. So that's what the where the future in terms of the way the things are going to happen. A little bit of more detail about how it's going to bridge the gap. It also gives a kind of some sort of a decision table about the some sort of a more weightage can be calculated with some sort of a decision rules, using different graphs, as I mentioned previously, which may call it in DMN definitions going forward, and all to it, right? But finally, what is the takeaway for all of us, that the context graph connects the facts of the moment of a decision, right? So that exactly where the architecture is going to evolve. and that is where the most of the company is going to work on future also. So you'll see this thing all coming very fast because of the speed of the innovation what happening currently. But this is what a takeaway for giving a context graph. So we learn also now context graph how it look like, right? Now, before I conclude the session, because we have only limited now, so given there'll be a very good recipe which we can talk in future and all, right? Whenever you want to discuss about this topic. You can also connect with me through aiwithsuchit.in if at all you have any questions further. And for you, just for benefit of everyone, I'll just give you maybe I have a link where you can connect for any questions you have that I would suggest you to do that. It will help you to, because it may be possible because of this, the constant what we have today is that we can only take the question the last, right? This is for everyone. So you can correct me through this, and any questions you have, do reach out to me. Now, coming back to the main topic, the way I'm thinking is that as a part of the last few minutes, so look at this, right? So there are a few green, there are a few purple. And if your recipe of an architecture, if you take this as a blueprint going forward, right? And stick this blueprint in front of you in your wallpaper and convert your problem into an outcome into a kind of a various stages of a signal converting into various, the context structures and then boundaries and so on. So, right? If you go just very diligently and all, you'll completely redefine your architecture. Not redefine, but you'll really think through what the architecture should require in architecture, right? What my intent in this whole process in last 1.5 year to 2 years is that can I help people real in architectural intelligence rather than the tool users, right? Currently, what happening is that when we see any kind of a, if we say that Claude has implemented this or Claude has launched this, AWS launched this, and there is a Google has launched the agent toolkit and all. I think we try to learn that very fast, and I'm telling you that's not the way the future is. And that's what those who learn the tools going forward. I mean, an example, when Jensen Huang 2 years back, he was saying that those who learn AI are the one who will exist. I'm saying that those who will learn just a tool and AI, they will not also exist. I'll say that, okay, those who really do a kind of a architectural definitions very clearly in their mind, tool will change, technology will change. But if their reference architecture is right with the problem what they're solving, and if they're solving really an extraordinary problem, they will be really called for. Otherwise, there is a less chance that you will do anything different in AI world. Okay. I think I'll take a few questions from, because almost all 3 questions I avoided. Yeah, Darshan, if you want to ask.
Sir, is there any references for the architectural?
Yes.
Like, if I see few of the means prompts,
Yeah,
so I can understand what better prompts I can make.
No, you can actually. So for that, whatever the link which I given you, right? So there will be few reference architecture definitions which I will expose you to through my website, and I think you can also refer it to. I'll also given kind of a links of where I'm referring to some of the blogs and as well as the oral architecture which I'm doing. So that will help you to go in detail.
Thank you.
Okay. Okay. I think there was few questions which are not taken before. Was there anything? Okay. Okay. So I think with all this thing, I think we conclude the oral session. Of course, there are few slides which I just want to give you an idea. Of course, it is a very theoretical slides. Hoping that you will become a good judgment engineering to do it yourself. Hoping that you will actually there are, as I said, a few of the, the way the future engineering or the future design engineering will depend on what kind of, few of the very a good slide around it, but intent is not that about that. Intent is only to give you an idea about the entire the what we started with, the raw data to the decision intelligence, what it takes from raw intelligence to a context of what it takes in between, right? So this is what we discussed in this last 2 hours. But that's what my whole intent was. Okay, so I think before do you, if you guys have any question, we can, if you want to convey your thought, no question, but convey your thought also is okay. So I'm okay for that, and we have 5 minutes for that. So anyone want to convey their thoughts so far so good on this subject with their own what they're doing, research and everything?
Yeah, before that, I would like to thank you so much, Suchit sir, for the insightful and the practical session. I am sure everyone got a much deeper and clearer perspective on how system design uh, actually works, and you make the session really very practical, particularly the Padlet activity, which everyone got to think and really applied it with real examples. And also I would like to thank all the participants to joining with us and staying till the end. So before you close, as sir said, if anyone has anything to share or any feedback or any learning experience, they can share it. Also, I have shared the WhatsApp link in the chat box. So those who did not join our group, so they can just join it. So they'll get all the reminders, updates about the all the future sessions that we'll be having. Thank you again, everyone. Have a great day ahead. Yeah, and you can just unmute yourself and
Yeah, if at all you have any question, do let us know.
I just want to share what I'm doing right now.
Yeah.
Actually, it is fully vibe coded, not that good of thing. And I am doing 3 projects right now. One was for algo option trading. I want to just show you my screen.
Yeah, yeah. Maybe so that can be taken up offline, because I just want to take up only those which are very quickly answerable kind of thing, based on the number of people which still exist now. Is that okay with you, Darshan?
Yeah.
Okay. But you can reach out to me. I've given you. Did you get my link?
Yeah.
Yeah. So you can reach out to me any of the channel. I think I'll be able to help you out. Okay. So any question? Anyone want to say anything? If no question further, then I think we can close the today's session. But do let me know if at all by chance you have any question or anything you want to convey.
I'll share the feedback form once again. So you can just fill that feedback form and share us your experience, your learning experience. We'll share the recording as well as the slides over the mail. And also you will get the feedback form link in the group as well. Thank you so much, sir.
Thank you.
All
Bye. Take care.
right.
Enjoy.
Have a great day.
Same to you. Same to you.